talk, I would like to give a little bit of gratitude to the people that motivated it. One of them is Natalie, who normally runs the meetup and who is taking a well-deserved rest. So thank you for covering for her while she's away, but also thank you to Natalie for spending the time with me to throw around some ideas. And I'd like to also thank the team that I work with at Black Book, the AI team who are here tonight, thank you. Because we have ongoing discussions/arguments around the topic of when is it really an AI problem, or what really is an AI problem, or I like to argue on the side of maths, when is it a regression problem or a neural network? When is a neural network not a regression problem? That was one that I got tripped up on for like a long time. They try and nerd snipe me. Got my eye on you. So that was the motivation for the talk. And then I realized after I wrote the talk, even though it's called How to Identify an AI Problem, I actually end up talking more about when you use machine learning techniques rather than actually talking about the real, rather than really delving into what is the AI. So I thought I might touch lightly on what AI is to me so that you don't ask me questions about it at the end and say, you never talked about AI, you only talked about machine learning. Anyway, so the way I think about AI, well, if you think about intelligence, any sort of complex reasoning that you put together demonstrates intelligence, and so then, by extension, I think when you get a computer to do that, then that's your artificial intelligence. It's kind of loose. We can debate it later. But what that means is a lot of the AI that we do is really narrow. So there's a lot of AI that does one thing. And once it becomes sort of everyday, we neglect to acknowledge that it's AI anymore. Like Google Maps, every time I ask for directions, that is AI, but it's in my pocket, and I forgot that that's actually AI in my pocket every day. So it's everywhere. And so I'm going to talk about maths, because it's my favorite thing ever. I'm also going to talk about data science, because I am a data scientist now, which is kind of a rebranding exercise. Right. And I will also talk about the company that has sponsored the drinks and that facilitates me practicing my craft as a data scientist. So I'll talk a little bit about Black Book and what they do. And then to illustrate my points, I will talk about 3 examples. One, which is an automation example that I think nicely illustrates what Black Book does in the robotic process automation space, but it's got a math problem inside it. Then I'm going to talk about an AI problem that I think is just a math problem. And then I'm going to talk about a big sticky math problem that I spent a couple of years working on that I actually think might have been better done with AI. So, the term data science has been around for a while, but it was popularized in 2001, which is when I was doing my undergraduate degree in maths and programming. And it kind of turns out what I suspected all along was that data science is just kind of glorified statistics, right? And machine learning, I suspect, is just dynamic statistics and optimization, which is kind of what my degree is in. So that really helped me when I, last year, took a couple months off to do a little bit of self-learning, and I went to Bali and hung out in a bamboo co-working space with high-speed internet, and it was really cool. I highly recommend taking a sabbatical to somewhere tropical. And realized that data science and machine learning is kind of what I've been doing all along. And I think this illustrates nicely, so it's Conway's data science Venn diagram. It illustrates nicely how it is the intersection of practicing your mathematics, practicing your programming, and getting experienced in putting those things together to solve real problems. So now I work for Black Book. They've been around for about 18 months. And a lot of their work, so it's a Brisbane-based automation and AI consultancy, and by automation I mean robotic process automation, which I hadn't heard that term until I moved into the business. And it's a lot of those processes in any organization where you're doing something a bit menial and repetitive and you are 100% sure that in this century a computer can do that for you. So we write little software robots that do a lot of those that automate a lot of those sort of front-end processes. So reading email queues and sending those emails off to the right business area, or what's another good example? Periodic reporting is a really good one. You know, if you see yourself printing out a report every day and crossing off lines using some set of business rules, we can automate that. That's like the bread and butter business. And so after 18 months, we've grown to about 30 employees. It was completely bootstrapped for the first 12, and then one of our largest clients, which is RACQ, decided that they would invest in us, and that's allowed us to turbocharge our growth, and so that means that we are hiring. So we have two main branches for our work. One is robotic process automation, so we have process automation engineers, and the other group is the group that they let me lead, which works on, I guess, the slightly more tricky things, which so far has been loads of fun. So here's an automation example. Yeah, be warned, I'm a mathematician, I'm heavily biased, and there is maths in this presentation. And there's mathematicians in this audience, so actually I'm more scared of them than you are of the maths in the presentation. All right, so we have an automation example. One of our automation engineers was out at one of our larger clients. Now this is a big company that has hundreds of warehouses and stores, thousands of products. Customers come in and order products from the stores, or they can order them online. So our engineer is out there helping them on their automation journey and is building them a couple of bots. The first bot takes their epic amount of daily emails and sends them off to the right business area. So that's one human who had to look at all the emails coming in and send them to the right people, and now we've got a robot that does it. That's nice. Then they said, all right, one of these queues is full of purchase orders. Can you get another bot to turn those into proper purchase orders and put them in our electronic purchase order system? Sure, no problem. So that's bot number 2. Now bot number 3, because we got our purchase orders in the system, can you then go and check stock levels and tell us, get a bot to tell us which of the stores and warehouses has the stock to fill that order? Sure, no problem. And then the client said, we have this other problem and we don't know how to solve it. If you can't ship everything from one warehouse or one store, what's the best combination of warehouses or stores to ship it from? And our automation guy went, leave it with me. And he came to me. I swear it was the most fun thing that happened that week. So I went, you can represent the availability across all the stores of all the different stock items. And then you can represent the cost of shipping it from any store. And then you choose which stores you're shipping it from. And it's, actually I think in this room, one of the mathematicians is probably the professor who taught me this subject the first time. And so you can formulate this as a linear program. And it's like my favorite thing in the world. And it's actually a very classical type of linear program. It's called a set covering problem. Let me Google that for you. So it turns out, not only is it a very classical math problem, there's actually some really nice, easy heuristics out there. So now we've got a bot that's got a little bit of code inside it, and it solves our set covering problem. So that's automation, contains math. All right, we have another client who I will anonymize for this. So I won't tell you what they actually sell. I'll tell you that what they sell is widgets. Classic widgets. All right. So they have this AI problem. Customers come in and buy widgets. You can buy a red widget or a blue widget. You can buy as many as you want, but they only sell them in singles. But what they think is, wouldn't it be great if we could sell combo widgets? So they want an AI model that looks at your transaction history, proposes you a combo widget, and then looks at whether or not you buy that widget. So here we have your transaction history, your magic box, the combo widget, and then what you actually did choose to buy from that combo widget, and that's how you train your model. Except because we've never had combo widgets before, I can't complete that loop, and this is not AI. Or I can't use machine learning to solve this problem. I can use math. So in my head, what this is it's a pricing model for combo widgets, and it's a predictive model for, given what you did in the past, what you can do in the future. I think if I was a proper statistician, I might call it out as Bayesian, but there's too many mathematicians and statisticians in the audience to bluff everyone on that. And they're in a really good mood tonight. All right. Maybe I rushed through this talk. Oh my God, it's going to be such a fast talk, and you can completely corner me and debate me on any of these things, because this is the last example. This is... what? Yeah, the mathematicians are allowed to ask questions. That is another one of my favorite mathematicians. Hang on, can you wait till the end, please, Dr. Nazarathi? All right. So this is the maths problem on which I earned my PhD. I'm an applied mathematician, right? And I worked in hospitals for a long time doing math, because that's what you do when you work in a hospital. So think about the emergency department. Patients arrive essentially at random, and when they get there, they need to be triaged. Then they might need somewhere to wait. Then they might need a treatment space, and they probably need a medical assessment. They might need some diagnostics. They might need some treatment. We might go around this loop a few times, and then they're definitely going to need to be discharged because you don't get to stay in the emergency department. That's not how it works. Right, so my thesis was about, if there's all this stuff going on in the emergency department, can I not produce and manage electronic task lists for all of the resources in the emergency department? Now, because I'm from the field of maths that does lots of scheduling and allocation problems, I formulate it as a scheduling problem, because it's what I do. And so when you do that, you look at the environment, you make some simplifications of your system state, then you distill your system into, you interpret your system into some rules that set up the structure for your schedules. Then you start scheduling your resources, and you produce these task lists. I mean, there's a little bit of a disclaimer here. So it's almost like when you think about a self-driving car, if the self-driving car gets in an accident and someone gets hurt, does the person who wrote the software get in trouble? So if I'm writing a task list manager for an emergency department and someone gets hurt, you worry about what's the ethical implication of that. So the idea of the implementation of this sort of system is it's a suggested task list, which is interesting because then I think there are some features here that lend itself to a really deep neural network And the reason I think that is because you take that task list that the system has suggested, and then you actually track what order those tasks were really done, and that becomes a way you can train a system. And then I think about the simplifying assumptions that I made on the system state. And the beautiful thing, or maybe the constant tension that I feel between maths and deep neural networks, is when you solve a problem with a math model, you make human readable rules. And when you solve a problem with a neural network, it makes its own connections and its own rules. And in a system as complex as this one, that's probably a benefit. Now, the other thing that I think about when I reflect back on the mathematical modeling and the algorithm I wrote to solve this is I set the parameters once, manually, experimentally. And I know, because I've worked in emergency departments, that sometimes they're busy and sometimes they're quiet. Some other emergency departments are big and some are small, and sometimes a doctor is sick. And so the way that the system works is constantly changing. So having set those parameters once and set them manually actually doesn't suit this environment. And so now when I look back, after rebranding as a data scientist, I think perhaps if I was going to have my time again, I would use some kind of deep neural network, and I think it would produce a better solution than the ones that I did as a mathematician. Which, for those of you who've done a PhD, I think it's like maybe a really hard reflection, or maybe it's a really common reflection to go back and go, if I had my time again, I would have done it completely differently. I just rushed through this and got to the end. So, my concluding remarks, which is in response to the ongoing discussions I have with my team about when is it just math, is that I acknowledge as a mathematician that sometimes deep learning can do better than math. And yet, yeah, sometimes, not convinced. And also as data scientists, I think one of the really important lessons that I'm learning is that depending on the data that's available and the thing that you need to learn, that should really guide the techniques that you use and the kind of tasks that you think you can solve. Yoni, do you want to ask the first question about my set covering problem?
Oh, thanks. I'm not used to this format, sorry. So, Dr. Ruth, can you explain this problem again? I mean,
I would like to know what is the best combination of stores from which to ship this order. So the order has multiple lines, and I don't have a single store that has all of the stock. Now, what I know about the stores is that I've got at least each line in at least one store, and I know that some stores are preferential for me to ship them from, right? So this is the idea of how much does it cost to ship my order. Like, it costs less money to ship it from a warehouse nearby than it does to ship it from some really small store in Bundaberg that happens to carry that line as well. So that's how we work out the cost. And is it more mathematicians laughing up the back or someone trying to ask a question? I can't tell now. So the basic structure of this problem that I'm trying to minimize the cost, and we call it a set covering. Did I call it the wrong thing? Is that what you're really calling me out on? Okay, just checking. Just checking. Yeah, the solution is definitely discrete. This is now turned into a math lecture. Be terrified. And that's not a full formulation. That was knocked up for the purposes of this presentation because I rubbed off the original discussion.
I thought this problem was part of the RAND Corporation, the Berlin Wall, in the introduction of the simplex, revised simplex type operations research type problems.
Yeah, see, operations research is exactly the specific field of about 80% of the mathematicians in this room. So, yes?
Well, as I said, I thought that problem, that very similar problem was from the 40s. 1940s, yes.
And this is why, like, this is my whole point. A lot of this, like, fancy new, like, machine learning is actually, like, it was 15 years ago that I was first learning it from work that had been done, like, in World War II. So you're right, 100% right. A lot of the maths that I see in machine learning is from World War II.
Hello. Another question.
Okay, I've just got a little bit of a question up the front about isn't this cost matrix, like this cost vector very traffic dependent? And it is, like setting up that cost matrix will very heavily influence the solutions that you produce. And that's part of how you iterate with your client. You're like, well, it's choosing these stores over those stores because the way we set up our cost matrix makes it lean that way. He's a data scientist. He's like, it's dynamic. Can't you just solve it with machine learning? Yes, you can always solve it that way. Hi. Oh, hang on.
Sorry about that. I just want to know, with all this rebranding everyone's doing,
With all this what?
rebranding,
Yeah.
data scientists, when clients come to you, that may be interested in AI in general, willing to invest because AI, do you try to explain your approaches? So some of them may just be math, or are you riding that wave a bit, do you feel, with the investment that comes in through deep learning?
Let me answer that by telling you what I said in my job interview, which was when I looked through the literature for machine learning and when I studied it, and I spent time like doing the courses and studying the books and solving the problems, nearly all of the underlying mathematics in there is from what I've been studying and what I've been working in all along. So for me, it feels like it's a small step. Like, I joke that it's rebranding. I think it's like, and
I guess I should ask, like, do you find yourself having to sell what you're doing as more than just math, perhaps, to get...
No, because it's equally impressive.
To mathematicians, certainly. And I agree.
I mean, I'm always really honest when I articulate to my clients the approach that I'm using. And so if it's got a deep neural network in it and we're using, I don't know, H2O AI, I'll say that. But if I have just done a matching score here and a matching score there and written an algorithm in the middle, like, I'll tell them that. But there's not a great difference between me having written an algorithm or a heuristic or me having plugged into a machine learning framework that uses steepest descent.
There is, because you can explain one and not so much the other, right?
Right?
Human understandable.
Well, and again, I think that's why I touched on the tension between, for me as a mathematician, between using a math model that has those human understandable rules and using a neural network which is kind of a black box, a little bit black boxy. There's a tension for me in that. But then, like when I reflect on my PhD, there are situations where that is entirely an appropriate method to use, because it is hard in some cases to articulate all of the rules. And actually sometimes it's okay to let the system articulate its own rules, because one of the ways that you become really good at being a machine learning practitioner is by picking really good metrics and by knowing how to train a really good model, which is also what makes you a really good statistician. Sarah, you had a question down the front.
One of the criticisms that's levelled against convolutional neural networks and the current crop of AI is that we kind of really don't understand what those black boxes are up to. And they've made a few gaffes, you know, calling someone of a particular racial background a gorilla, for example. And when that happens, people just throw their hands up and say, look, we've got no idea what's going on inside the black box. Yeah, exactly. So I'm just thinking that maybe if we use mathematics to solve a lot more of these problems, you know, if you look at that hospital queue and you decide that that's represented by a Poisson distribution or whatever, and you come up with a mathematical model and you write it all out, and that's subject to human inspection. You can look at that stuff and say, all right, I understand what's going on here. So at least then it's responsible to some person who's looking at that stuff, and you can have an element of social responsibility. Is that?
I definitely think that if you're good at your linear algebra and calculus, then you will better understand the network architectures and better understand how to define a good problem. In fact, I think one of the things I worry about is people using these nice APIs that allows them to dump some data in and get some junk out and not really know, and just go, I don't know. It said it was 85%. You know, is that good? And so I think if you do, I think with the benefit of my mathematical background, I think that's probably going to make me a better practitioner than someone who comes at it from just, I don't know, a hacky background. And it's actually I think what you're saying is actually here. It's called the danger zone. So if you just learn how to use the APIs and then you just like train a bunch of models, then you are just in the danger zone. And I think that's exactly what you're trying to address. When I talk to clients who are a little bit nervous about using an AI model for some reason, I always say, well, we're going to leave humans in the loop here. Like, we're not just going to let the AI make a decision and then like propose a bunch of things to the clients. What we're going to do is we're going to let the AI make a decision and propose it to your human experts. And they'll get to be the gatekeepers because they get to train, like they get to do that feedback loop about whether or not the model is producing garbage. Sorry, say that again.
Could have been good mathematics.
Good model diagnostics will always be good gatekeepers. Good model diagnostics. So what you're saying, like if you have a good mathematical test for the quality of the output, if you specified your model in a nice way and your metrics are really good metrics for measuring model quality, then yeah, you can use that. And that should be a good judge of quality. But if you're doing natural language processing, then it gets really muddy and really hard to judge the quality of the sort of context that you're reading in your data. I have a question here.
Thank you very much for coming along and giving the talk. If you can go to a couple of the slides on your thesis, particularly the networking sort of diagram.
This one? Or this one?
That one. So my question is, in reflecting back on it, if you're going to train a neural network, is it one neural network from beginning to end? Or is it like I see 3 different networks, or maybe I see 4, 6, 7 different networks? Do you know, sort of, what would you do now?
think that question would take me 3 months to answer.
Wow.
I have a question on the following. No. I have a question on this one. So you said that when you gave them the optimised task list.
People at the back can't.
Okay. So when you gave them the optimised task list, you then fed back the information about how the tasks were actually done back into the system to train it. But you were trying to make the system better. So did you ever find bad habits just got trained as the right way to do things?
So this is the thesis I didn't do, but that's a really real risk. And I think that also harks back to what Sarah was saying about when people use an AI and they train it to say bad things, which is what happened to Microsoft. They had to... And RoboDirt, look, there's so many really good examples of AIs that are trained by really bad humans. And that's the real risk. It's exactly right what you say, and right that myself and other people from my research group identify as a risk for proposing these sorts of systems where people could die. I mean, this is not just a funny chatbot on your bank's website. This is a task list in an environment where people are sick, just like we look at our self-driving cars that are driving around 1-ton metal boxes that can kill us. You know, so they're real risks that you have to address. I don't know how I would. I'm not going to do another PhD, but thanks for asking.
Sorry, me again. No, over
Right.
here. Taking on, I believe, Sarah's comments at the front, the bit that concerns me about the neural networks is it being a black box and coming up with insights that you don't expect. So, citing last century US Department of Defense aerial photos, trying to find tanks, and all it did was work out overcast or sunny days as a result of that. The bit here that worries me is that, especially in intensive care or emergency, is that it may have an insight that a particular doctor has a high mortality rate. And it turns out that's because he's the most experienced, and when it's a toughie, they'll hand it over to that person. So without the insight with regards to the behaviours or so on, the neural network may come up, avoid this doctor at all costs because they're the worst ones with regards to failures and deaths and so on. So what's your view then with regards to assessing the validity of the insights?
I actually did some statistical analysis on looking at different DRGs, which are diagnostic related groups, and then I was only looking at hospital length of stay, I wasn't looking at mortality, but looking at empirically what are the factors that influence length of stay, and things come up like this particular doctor, or being admitted on a Thursday as opposed to being admitted on a Monday. So if you're admitted on a Thursday, you will stay longer than if you're admitted on a Monday. Because pharmacy don't work on the weekend, so you can't get your drugs for being discharged over the weekend. That's why. But you do get those sorts of insights, like within something like a diagnostic related group, which is a broad category, it may look like one doctor is dealing death. So then you have to look at the fidelity of your inputs as well. And that sort of insight, if you have enough fidelity in your inputs, that sort of insight will come out in your outputs. Or it might just be a flag so you can go and have a conversation with that doctor. But yeah, it's interesting because I've seen it before. The other thing I've seen, my computer went to sleep. The other thing that's true is there's actually a higher mortality rate on weekends and holidays. Yeah, scary. And nobody really knows why, but there's two common theories. One is because over the weekend, it is a slightly smaller staff group and a slightly more junior staff group that is working the hospital over the weekend. And the other reason is if you think about how sick you are on a Saturday when you drag yourself into emergency, compared to how sick you are on a Monday morning just before work when you drag yourself into emergency, you might actually be sicker if you take yourself to emergency on the weekend. So interacting factors, very pertinent point. And these are the ethical considerations these are ethical discussions people are having now about cars that drive themselves or robots that do surgical procedures. But I'm a mathematician, so it's outside of my field. I feel like there was a question up the back, and I think it was Elliot. Get yourself a microphone. All of the questions that are asked by people whose names I know are probably plants, so they better be good questions.
Okay, well, I'll give it my best shot. I'd like to preface this by saying that I believe in holding speakers accountable for the titles of their presentations.
Oh no!
And with that in mind, I'd like to know what, over the course of your work and those 3 distinct pictures you painted for us, have you learned about how to spot an AI problem? And I take it that by that you mean identifying the sort of points of inflection where AI can make the biggest difference and has the lowest risk of making spurious correlations. I assume that's what you're getting at. So yeah, what have you learned?
I've learned that because I have quite a broad background across a bunch of mathematical, algorithmic, and now sort of machine learning, natural language processing, my least favorite thing. Because I've got that broad base of experience, I constantly draw on all of it. So it's like people come and they're like, oh, I don't know, we've got this problem. And they may or may not even use the word AI, but for me, that's like the machine learning stuff and the neural network stuff have just been added as related tools in my toolkit. And that's how I deal with it.
Thank you.
Thank you.
So you know, with these you know, new fields that are coming through, the machine learning, the AI, have you needed to expand your maths and your understanding, and had to, I guess, you know, learn other fields within maths, or is it just all the same and you're just applying it in a different way?
I am having to learn more programming at the moment, like learn better programming. Thanks, team. Because the quality of my code has to be readable by other humans, which is new and terrifying. But I've been learning lots of new things under the heading of machine learning is where I'm focusing my personal learning.
So I guess you're compounding your maths with other areas in that space.
I feel very much like all of my education up until this point was possibly the strongest foundation anyone could have hoped to have to then be working in this field now, because everything that I know from my undergrad, like all of the calculus and linear algebra, all of the statistics and all of the optimization are the scaffold for all of this stuff with all of the cool new labels. Yes.
Second bite of the cherry, unless there's someone else that... So my question is not well formed, but I'm starting to see a spectrum of problems, and when are you starting to see this falls into this class or that class or some other class? Like, is it a classification sort of challenge more so now?
You mean
Neural
like
nets.
talking to a client and understanding from the beginning of their narrative
So,
where the
so-
problem's going to go?
So I think you were sort of saying that natural language processing, oh, that's hard. So when, images, oh no, that's easy. Natural language processing, that's still in the hard basket. When are things starting to become very tractable, and when are they still not quite sure where we'll find a solution in?
In the business that I work, because we work as consultants, then part of our scope in our interaction with our clients is bringing their expectation into some kind of tractable framework. Because I'm not a salesperson, but our salesperson who isn't here might go out and promise the world. And then when I hear about it, I'm like, no, I need to talk to that client and I need to understand what they really want before I can estimate what we can really deliver. And I think that's a real challenge and a real gift. And also another one of those tensions inside like how our business functions is making sure that we scope problems properly so they are tractable and deliverable, which is also part of that learning curve for me on software projects.
Thank you.
Thanks for the presentation today. So I am a mathematical ignoramus. My background is in healthcare and economics, but just looking at the linear algebra problem, it looked like a upside down version of the traveling salesman problem. Closely, yeah. So, and just sort of extending that to the emergency department scheduling problem as well. Are you saying that neural networks can have better approximations to potentially NP-complete problems than straight up math? And are we getting closer to that area?
I think my current opinion is there are some really complex systems that we might be able to make better solutions to an extent with deep neural networks. And the reason I think that is because of the intricacies of trying to simplify the state and the rule set so that you can write your algorithm for it. And that the NP completeness is to do with like how big your solution space becomes, and that is less of a problem to a deep neural network. So I think there are some cases where those kind of algorithms might be outstripping the field from which I originally came, but that's actually probably an argument I'm going to have at dinner.
So, if you had to design a series of guidelines for a layperson to differentiate an AI problem from a math problem or from a process problem, what sort of thing would you include?
That's a really hard question. It's as hard as the one that Chris asked me last time I spoke in public. I think you two are in cahoots. Guidelines. My guidelines for specifying a nice problem. And this is actually a discussion I had with someone today, was all around that person having not articulated properly what the inputs were and what the outputs were and how they were going to measure the quality of their outputs. And that doesn't differentiate a math problem from an AI problem. It doesn't differentiate a math problem from a statistics problem either. What it does is it differentiates a well-defined problem from a poorly defined problem to which you can have the best model, but your problem is poorly defined, and we all know what happens when you put garbage in. Okay, this is going to be a tricky question. I know this person.
Thank you, Ruth, for a very nice presentation. It's always a pleasure to see former students doing well. Aren't we saying in all this discussion that in a way AI models work better where you don't have to worry too much about the worst case? Because a mathematical model is equipped with a theory that will tell you what can go wrong. Okay, whereas an AI model, by and large, if it's trained on a certain set of data, may not be prepared to deal with with an instance which lies outside of the domain to which it has been exposed. Yes. So it's the problem of uncertainty quantification.
I think another really important part of that argument, and what was I going to say? I had something really good for this, and it applies to both neural networks and mathematics. And it's very much about like building a model for the data that you know about. Oh, it's about rigor. That's right. And I think mathematicians are trained very much to respect rigor because that's our thing. And I think the risk with a lot of what's happening with these black boxy type neural networks is we lose the ability to understand how to impose the kind of rigor that stops us from falling into those traps that we're familiar with from having studied optimization. And I think that's a real trap. I think that was the danger zone. That's what happens in the danger zone, is when you're not prepared for edge cases, or when your training data doesn't cover what's in your real data, and you don't know how to stop your model, or you don't know that your model's done it because you're not checking.
Could we get last one or two questions, and then we can move to drinks and food and keep networking? Yeah?
Yeah.
Cool.
Could you speak a little bit about performance of your algorithms when compared to neural networks as such? Did you have the time it takes to produce a result as compared to a matured model that would give results out?
So I don't have any example cases to tell you where I've solved it using both what I feel is classical optimization or operations research methods versus machine learning methods. I don't have any specific examples to do like a direct comparison. And what I do, I'm quite new with this business. Like I've been with this company for 2 months, right? So my portfolio of projects that I've worked on is like almost every week we get a new project to try and whip up a demo or a model for a client. So it's really high paced, and at this sort of early stage of our AI team within that broader business of Black Book, is we've been able to do a lot of specifying a nice model or scoping a nice project and producing a demo. So we're really only at the demo stage with the projects that we've tackled in our particular small team within that broader business. And so I don't have the kind of direct comparisons that I think you would like. And looking forwards, I don't know how much time the company would give me to go off and do that research project, but I love it. And I am I'm intrigued by how deep learning would have done differently on the thesis on which I earned my PhD. I'm actually really intrigued by it, but it's unlikely that I'll have another 3.5 years of my life to devote to it.
Last question.
Hi, Ruth. I don't think this is a very serious question, but it sounds like the question is how to identify an AI problem is a classification question. Could you train an AI to classify the problem?
I actually don't think that computers are good enough yet to put mathematicians out of their jobs.
Thanks.